So the next topic we're looking at is formula or formulae. And we use formulae when we do a calculation many times and things have the same relationship between them every time. So an example of a formula is speed is equal to distance over time. And in this formula, like in many other formula, we have letters that represent something in real life. And you've also seen it as a triangle. So that if I want to know the speed, I cover S and I divide distance by time. These formulas are useful because if you have a value for t and a value for s, but you need to know what the distance is, then you can plug the numbers in. So let's say I have time 1 hour and I have a speed of 60 kilometers per hour. Then I can put the s in here. 60 is equal to d over 1. Then I multiply this 1 by the 60. And I get that the distance is 60 kilometers. Now that's a very easy formula that you have used many times, but it's just to give you the idea of what a formula is. Another example is Fahrenheit to Celsius. There's a formula for calculating degrees Fahrenheit, as they use in America, to degrees Celsius. So I've got my, let's call it C, my Celsius degrees, and I've got that multiplied by 9 over 5 plus 32, and I get degrees Fahrenheit. And then I can rearrange this formula so that I have an expression for degrees Celsius. But they're just some examples. Let's look at an exercise from the book. So this is page 54, exercise 5, question 1. It says, the final speed v of a car is given by the formula. So we've got v, the final speed. Let's just write it down, final speed. And it's given by, or it can be calculated by the formula, v is equal to u plus at. And then it tells us what these letters mean. So u is the initial speed, and a is the acceleration, and t is the time taken. So we know that the final speed is going to be equal to the initial speed. So let's imagine that we have a car and it is moving at u equals 15 meters per second. A is 0.2 meters per second. So the acceleration is always measured in per second. So you can see it like this, per second squared. And time is 30 seconds. So this is nice because all of our units are matching units. So I've got to make sure that I've got meters per second here, meters per second here, and not something strange like kilometers per second, because then I would need to convert those kilometers to meters. But in this question, we've got seconds and minutes. And meters. So they're all the same. They're all matching units. So let's put some things into this formula. We want to know the final speed. So we don't have a value for v. V is equal to, we just plug this number in. 15 plus 0.2. I'm going to put a bracket here so that I don't forget to multiply first. 0.2 is the acceleration, and time is 30. So let's do this calculation. You can do it on a calculator, or if you can do it on your own, then you can do it in your head. But 0.2 by 30 should give us 6. 15 plus 6 gives us v is equal to 21. And I know that the velocity is a speed, and speed is measured in meters per second. So it should be 21 meters per second. So that's our answer. Now you can go on and do some more questions from the book, but I'll do another question here if you're struggling. So the next video is another question from the formula section.